In this video, the design and production of the drone prepared by Arileria for the SUAS competition is explained. Our team consists of undergraduate students who are aviation enthusiasts from many departments.
Hi, I am Altuğ. I am a mechanical engineering student at Kocaeli University. This is my third year with the team and at the same time Unmanned Vehicle System Technologies. I am the team captain of GSB KUGEM Arileria. I am responsible for the functioning of the team and the distribution of the work.
Hi, my name is Fatih Burak Koca. I am a mechanical engineering student at Kocaeli University. This is my second year with the team and at the same time SUAS technologies. I am member of mechanical team and I am responsible for design and analysis.
Hi, my name is Mustafa Tugan. At Kocaeli University, I am a mechanical engineering student. This is my first year with the team as well as with UASS technology. I am a member of the mechanic team and am in charge of aircraft design, manufacture, and analysis.
Hi, my name is Musa Can Karaca. I am a mechatronic engineering student at Kocaeli University. This is my first year with the team and at the same time SUAS technologies. I am a member of electronic team and I am responsible for battery systems, power electronics and BLDC motor controls.
Hi, my name is Mustafa Görkem Savaş. I'm an electronics and communication engineering student at Kocaeli University. This is my second year with the team and at the same time SUAS Technologies. I'm member of electronic team and I'm responsible for electronic integration, power calculation. Also, we made our own ESC this year. I was responsible for PCB design.
Hi, my name is Fatih. I am a mechatronics engineering student at Kocaeli University. I am responsible for general drone design, electronic integration, and embedded system software. We wanted to make our own electronic speed controller this year. I was responsible for PCB design and software.
Hi, I'm Emin. I'm a mechanical engineering student at Kocaeli University. This is my second year with the team and at the same time UAS technology. I am member of the developing team and I'm responsible for the developing algorithms, image processing and autonomous flight in our unmanned air vehicle.
Hi, my name is Merve. I am a chemical engineering student at Kocaeli University. This is my second year with the team at the same time UAS Technologies. I am member of organization team and I am responsible for managing social media accounts and finding sponsors.
Hello, I am Batuhan. I am studying mechanical engineering at Kocaeli University. I am in the third year of my 4-year undergraduate education. I have been with the team since September 2022 and I work in the team's mechanical department. My responsibilities in the team are to make mechanical designs and analysis of vehicles. I am involved in the design and development of useful systems needed for missions. I am also responsible for flight mechanics and R&D.
This table shows us the missions, the descriptions of the missions and the acceptance criteria for a successful flight. The Pixhawk orange Cubus is used as a flight controller. in our vehicle due to its ease of use and open source code. ESC with 8SAP Valor used as speed controllers. The desired thrust is provided with the help of 6 propellers connected to the engine. Siniski B4014 is used as the motor. This motor has been chosen because it provides sufficient power to our drone and is efficient. Jetson Nano was USAID's mission computer for image processing. Receiver communicates with the remote. GPS module is used to track the drone instantly. 6 soft LiPo battery was to provide the power required during the mission period. Telemetry holobro was preferred for our vehicle to communicate with the ground controller and transfer instant data. The team decided to build a drone because of its payload capacity and fast completion of mission. This section shows the construction stages. When choosing a camera in our imaging system, the small footprint and ergonomics of the camera were our priority. We examined the features of 3 different cameras. These are shown in the table. Among the cameras we reviewed, we chose the most reliable, stable, and healthy GoPro camera. Motor's price, weight, load temperature were examined in terms of 100% throttle. Siniski 4100 was chosen because of the same current value, higher thrust and starting. Our team examined tricopter, quadcopter, hexacopter, multicopter during literature phase. We decided on hexacopter, which has high stability and the ability to carry heavy loads. We chose carbon fiber pipe with high strength and low weight for the arms carrying our motors and easy to process, and cheap ply material for the body carrying our electronic components. The ground control station is designed to perform manual operations, observe the data needed in the competition and transfer it to server. Information such as drone location, number of satellites connected to GPS are on the interface in real time. Flight boundaries, marking, and drone position related to the flight area are displayed on the map in the interface. According to the system design, the image and flight data on the drone must be transferred to the GCS in order to perform the tasks. It was decided to use the holobro telemetry module in order not to interrupt the data transfer. RC receiver and transmitter will be used by the pilot to control. Drone, the radio controller shown in preferred because it has a long range. DroneKit has a Python library that allows Mavlink's commands from Jetson Nano to be sent from the drone computer to the Pixhawk Cube flight controller. But working with DroneKit is getting harder. The Mavros package can be used to open the door to many other ROS tools and utilities in addition to getting the same functionality as DroneKit. Therefore, ROS will be used simultaneously in DroneKit. This is our image detection code. There is a picture in our coding file. We will detect it to shapes, and we define object with their shapes. There is a different object. We detected whole object with their shapes as. The water bottles prepared for the task. will be released to the determined targets thanks to the task mechanism working together with our image processing code. Mission Planner will be used to run autopilot, with our Pixhawk Orange Cube Flight Controller running our DoPilot. This allows the team to manually create the required waypoints for the autonomous operation of Arileria. The provision of various features like autonomous takeoff, waypoint navigation, autonomous landing, and a rich set of fail-safes proved to be fit to handle the SUAS mission.
Gel Merve gel. Gel ben buradan atış yaparım oraya.
Yukarıdan çık. Olur ama çok yukarıdan çıkma. Yazıyor değil mi şu an?
Safety is always one of the important factors for aviation. Our main goal is to eliminate the security risk as much as possible. For this special purpose, all mitigations are taken into account and closely followed by each team member. Risk analyses are made in production, and efforts are made to prevent potential risks.